transect aboard the Polarstern in 2019, and they later co-founded the Blusink, an ocean-based carbon removal startup dedicated to restore marine ecosystems at scale by integrating biodiversity restoration into climate solutions and advancing an economic paradigm that values ecosystems alongside carbon. So before I pass the microphone to Lorena and Anjana, I want to let you know that this webinar is now being recorded. You can get more information about NANO and the NanoDove project in our website or social media. And Lorena and Anjana will present for the next 30 to 40 minutes, and then we will follow up with a Q&A session. So once again, thank you so much for your time.
Before I start, I just want you all to know whenever you want to jump in and make questions, that'd be really nice. So you do not need to wait until we're finished with the presentation. We really just want to make this a conversation for
All
anyone
right,
that
so
is out there in a science career interest in entrepreneurship as well.
that's okay. So I ask you, anyone that is interested in making a question, either type it in the chat or use the raise hand button so we can see it and interrupt in a less abrupt way.
Cool. Yeah, that works.
Thank you.
Okay. Hello, everyone. My name is Lorena. I'm Colombian originally, a biologist by background. Did a couple of other, research years studying material sciences. I, as Lika said, went on board the Polarstern in 2019. By then, I was already sort of transitioning. So let's say, like for now, we'll say my background is a mix of biology and material sciences. Um, and I don't know, Banana, if you want to introduce yourself already before we start.
Yeah, sure. So hi everyone, my name is Anjana. As Laura calls me Banana, but yes, so my background, no worries. It's a joke that we developed on the ship and it stuck. My background is, as Lika said, in physical oceanography and Antarctic sciences, and then I made a shift to. I was also in the middle of a transition when we did the expedition, so I was going from academic research on Antarctic ice shelves to working in industry. So right after the expedition is when I transitioned to industry. And yeah, that think Lika's already done a great introduction of ourselves and our backgrounds, so I'm not gonna continue on that. But yeah, I'll hand it over to Lorena.
Sure. So, in this talk, we're gonna tell you a bit about the research and the science behind Blusink. That's gonna come at some point, but we especially wanted to focus it on our lessons and the messages we've learned and kind of like transmitted throughout our experience founding a startup, which is something that definitely, like it's not something that you're scientifically trained to do so, but rather a set of skills that you learn in the process of founding, right? So we want you to think about this talk as we're going to tell you things that we figure we needed to still continue to learn after our scientific trainings. When building and when trying to translate an idea into the real world, right? Like just get an idea that it's probably scientific lab scale and turn it into something scalable that people and communities can apply in their local regions. So those three messages are, and they're going to come across the presentation. The first message is your career is not linear, right? So you're right, that first curiosity that probably made you go for a science career is the same curiosity you need to stick to and really just make it make sense across your scientific career. That probably can be a scientific career and can have a mix of other multidisciplinary skills, as I said. So just stick to curiosity, not titles. We're going to be talking about that. The second message is science is necessary, but sometimes not sufficient, especially if you're pursuing applying a scientific idea at scale and if you're pursuing merging science with all of the other spaces that can be the business space, the regulatory space, the community dimension. And then the third message would be resilience sometimes supersedes brilliance, right? We're all very brilliant in the scientific community. You meet all sorts of very brilliant people. You need to be resilient to keep pushing and to keep acquiring other skills that are might result uncomfortable for some for a scientific trained mind. We'll also, try to give you a couple of anecdotes about that and how we've been approaching that lesson for us. So to start, and just again, to make sure you guys are not too shy during the conversation, I want you to raise your hand if you thought you'd become a startup founder when you started your PhD or your master's, whatever type of scientific program. And as I do this, I realize probably the question should have been the opposite because we're gonna find more of the other. So I guess I'll change it now. Just raise your hand if you never thought about becoming a startup founder.
We have
Eberhard and Lika are very. Oh no, Eberhard didn't raise his hand. Leonard.
Cool. So I guess, that was also a surprise for us. So I'll tell you a bit more about, how my career didn't go linear and what I was doing before founding Blusink. So as I said, I was a biologist by background. I always studied coral ecosystems and Colombian originally, right? So sort of like when you jump into marine science here, it's a lot about the tropical ecosystems, a lot about coral reefs. We have a bunch of those in the Caribbean. I was thriving and happy doing that. At the same time, I was always keen to just chemistry and other more lab-oriented topics. So for me, it was a merge of just baseline climate research and coral reefs. And that, of course, like when COVID hit, it was a shock because all of us coral researchers were really dependent on field trips and field work to gather our data. So by the time I think we had just come back from, like from our Polarstern expedition, I had gathered some data on a material I was creating to, by then, standardize bioerosion measurements and coral reefs, right? So my whole concern was, the fact that we all coral researchers in different labs across the world, we were using different methodologies to measure that bioerosion. And so we didn't have comparable data between reef sites. So that was my concern. I wanted to create something. By the time I also knew somehow I was, more keen to develop things more on the innovation side, where like I felt myself an inventor. I wanted to invent something. I already had that seed to think about IP. When the COVID hit, of course, I was away from the ocean and from diving to gather data for maybe 2 consecutive years. And that time I used to think about other things that I could explore. And that was, without me knowing during the time, developing an IP and patenting an idea. I just want to take the opportunity. Eberhard is here. I'm just gonna give him a quick shout out because by then like part of the reason I was oriented to think about that was because we had so many conversations on the ship, and probably I was a bit annoying just like chasing him, being like, hey, what the heck is technology transfer, right? And so during that COVID period, I was like, hey, maybe, like what I can do is just take whatever research I already have and the concept idea I already have, turn it into IP so we're ready whenever COVID ends, right? So that was my period of, wait, is this IP? So I worked with my university on it.
Lorena,
I know,
sorry to
yeah.
interrupt. What is an IP?
So IP is intellectual property. That's what it
Okay,
stands for.
thank you.
And it's essentially an innovation, right? So the key characteristic of IP is something that is innovative, that no one else has, like done, replicated, or published, right? So as researchers, what you need to have into account is whenever you're thinking about IP, we researchers are very trained to publish our ideas, right? To share the ideas, to just yeah, just publish on scientific papers. That's kind of like the sequence of actions that you take, right? when it comes to IP, it's kind of another perspective because the other fact or the other truth about IP is the IP is a tool that you use to exclude people from markets, right? From the usage of certain knowledge. So it starts touching on IP as a researcher for me was also the gateway to think about businesses, just because of the function of an IP, right? So that's when we started working on the IP, just again writing down the concept in a legal format so we could file for a patent. And that all happened during the COVID period, at least in Colombia, right, which was around 2 years. I know it varied between countries. Funny enough, when the COVID, like when the quarantines were canceled here and we went back to the places where we had deployed the material, we realized the material wasn't so good to measure bioerosion on the corals, but it was really great at growing coralline algae. And we had some, indications of alkalinity of that material in the water, and we also noticed there was a local raise in alkalinity in those deployment sites. So that's when we started thinking about blue carbon as a concept for this development, and then blue carbon as a market. So, like I guess I'm gonna stop it here because we're gonna be talking more about Blusink later in the conversation. But I also, want to go back to the anecdotal and was during that COVID period, I was filing my IP, but I also had started researching with a deep sea researcher in the Smithsonian, which for me, it was a dream job when I was still thinking about, like I'm gonna finish my master's, I'm gonna do a PhD, I'm gonna do my postdoc, I'm gonna find a great job at a great research institution. And so by then, I think I had published one paper and did some research. It was a really great thing. It was gonna take me to submarines and more ships, which is something that I really adore. But it was also the raw moment of deciding maybe letting go that opportunity to take a PhD offer that I had in the Smithsonian to pursue Blusink as an idea. And then Blusink is our company, where again, I'm gonna give more context about this. So careers are really not linear. And I think by then, something that stick with me is against the uncertainty of maybe not following the linear path. Um, it was it was prevailing the curiosity about the research I was deeply interested in and new things and new skills to be developed. So yeah,
Yeah, I
but then you
can
can go ahead.
jump in here and kind of echo the same message about how my career was not linear either. When I got interested in climate science, so my background is actually my bachelor's degree is in physics, and I just knew I wanted to do something in climate, something to help the climate change problem. And I got in, and I did that through research internships. So I did physical oceanography. I started out in Antarctic research at the Potsdam, and I was sitting behind a laptop doing these like models of how fast Antarctica is melting. But I was like, okay, but how do we solve the problem? And science was kind of teaching me more and more about the problems. And I was looking around and I was like, how do I think I know too much about the problem. And now I want to know how to execute solutions, right? And in parallel, as Lorena was developing all of this stuff in Colombia, I was like, how can I go into the real world and make change using climate models? And that's, I think for me also, it came down to should I pursue a PhD or should I go deeper into research or should I join industry? And the first question I was faced with was, who hires a climate scientist? Like what do they do in industry, right? Where do I get a job? So I started researching a lot about that. And I was like, okay, worst case, if I don't make a role in the industry, then I'm gonna do a PhD. But the PhD was the backup option. And I was just adamant that somehow I need to find a job. I wanna know what's going on in industry. And I learned about climate risk analysis. So apparently there are industries, reinsurance industry apparently, that does large-scale climate risk analysis for projects. I'd never heard of reinsurers before that. I don't know if you guys have heard of them. Basically, if you think of insurance as insurance for yourself, like health and life insurance, reinsurance is for large infrastructure projects. So if your government is building a bridge, a dam, big buildings, they all need insurance. And that insurance comes from reinsurers, right? So they had this whole industry of looking at risk towards those infrastructures. And obviously, these kind of infrastructure is faced with climate risk. So I was like, oh, okay, that's interesting. Climate scientists need to be valued because, climate risk is important for a lot of industry. Now, that led me to finding out about all the kinds of infrastructure that's impacted by climate. And something that is very important for everyone is energy, right? So I've stumbled into the wind energy industry. I was interviewing for roles both in reinsurance as well as wind. And wind infrastructure, for example, is the wind industry itself. It baffled me how um, different scientists look at problems versus how industry looks at problems. Because in climate science, we were taught that, you look at these large-scale climate models, but you never assume that anything is 100% accurate because it's not, right? So you're going in to understand uncertainty, to understand like, oh, we shouldn't do this because maybe this would go wrong. And then you go to industry, and in wind industry, my ex-boss, when he was hiring me, he told me that he was working in the industry for 15 years across the world. And what he observed was there were no weather specialists, there were no climate specialists, right? And this was an industry that had existed by then for around 10, 15 years. And I was like, okay, but your your economic principles are based on the existence of wind and wind patterns. Why would you not hire climate and weather specialists? And his response was that because the wind farms were developed originally in Northern Europe, the patterns for wind there are quite stable. So, for example, in the middle of Germany, you're not affected by tropical typhoons, right? So your wind patterns are going to be very stable, and the industry assumed that the last 30 years of wind patterns are going to be the same for the next 30 years. Now, what they did was these principles became ISO standards, and they applied those standards to the tropics. And the tropics, when wind farms were developed in countries like Vietnam, Bangladesh, industry started losing billions of dollars because typhoons, low wind periods, El Nino, La Nina, all of these patterns were like affecting these wind farms, and they didn't really know what to do. And that's when he saw the gap, right? And that's when I saw how business works to solve problems using science, because you take a real world problem that the industry is not really attuned to, and then you look at how science can help it, right? And then he was like, okay, I'm going to create a role for a climate researcher to come in and create models to understand how these wind farms are going to be affected long term. So essentially to say, yeah, careers are not linear, and sometimes you can create your own jobs.
So,
Yeah.
like we're gonna spend some time talking about the expedition because that was really part of how careers are not linear in the sense of that expedition. I think for all of the crew, for all of the scholars on that expedition was completely unexpected and completely eye-opening. Um, and for this to say, like for I don't know, the age range that we have in the crowd today, but I would just like to say for all of you early careers, apply for everything that looks interesting, as crazy as it might sound, because it really can bring the untangible knowledge, the knowledge you're not gonna get from a textbook, from a classroom. It's gonna bring all of that and build your skill set, kind of sort of to say that. I know there someone raising their hand? No, I guess not. So I mean, we were part of the SONA 2019. That was a cruise track um, from the Falkland Islands, so just an island next to Argentina, to Germany. And I guess, like we had many invaluable uh, knowledge that was more the very fundamental science knowledge coming from it. I just mentioned, but also, multidisciplinary, right? Like I just mentioned IP earlier. But I think one of the most valuable things that we got from the expedition was the network of scientists, right? Because by no means, get from this presentation that we're saying science is not important. Science is everything. Science is fundamental for every real human progress. But so it is to network with different people and understand different realities. So from this day, the network that we gather on Polarstern has been beneficial even for Blusink, right? We can probably zoom in into that topic when we're showing you the map of deployments and Blusink size to this date. But many of those projects have been through the scientific network that partially we did also on the Polarstern, right? Um, so yeah, just a quick shout out to the expedition, I guess, with this slide. I don't know, Banana, if you want to add something else.
No, I would just say, yeah, the friendships that we made there, we're gonna touch on that later as well. But yeah, people connections are so important, and we're forever grateful to Sonat for introducing not just the both of us, but also Lika, Eberhard, Amabel, who's here. Yeah, and we still have very useful ties to this day.
Yeah. Oops. Okay, so message number two, there's more to science than science, right? As we've been stressing so far, science is not just the concepts and the scientific knowledge. Science is also networking. Science is understanding how to translate an idea in a scalable way. And that for us can be engloved, I think, in the word Blusink, right? So we're finally introducing Blusink. So Blusink is our company, which is a climate and restoration company. We've been out there for something like 5 years. And essentially, what we do is we have a technology that is capable of capturing carbon in an inorganic way, so inorganic carbon through a chemical pathway, and later transform itself into something that Anjana has very, in a smart way, phrased as luxury housing for biodiversity on the seafloor. So that's what we do at Blusink. And as Blusink is a for-profit company, that's been the fundraising part and just building the company, building the structure of the company, the business model, and the client segments of that company has been a whole journey. So that's something that we especially want to touch on today. And as long as Blusink is a science-based company, there's more to science than science, right? So um, yeah.
Yeah. So I mean, we'll explain more about Blusink right after this, but um, just to just to note that both of us are from science backgrounds, and therefore, when we started, when Lorena called me one day and she was like, "What are you doing?" And I was like, "I'm kind of bored with my job, and I'm scouting for new things." Right? She's like, "Good, I'm looking for a co-founder." Um, at that point, I personally had no clue about what venture capital does. I knew venture capital existed, but I didn't know how it functioned. And I certainly did not know what the GP of a VC means, right? Now I know it means general partner of a venture capital firm, and they're really important, and they're the guys that make or break the decisions of funding. I think the Lorena knew all this because I think Laura, you can explain that about the START program a little bit right after. But essentially, she had done an accelerator program that helped to translate patents into business ideas, right? So she'd heard of that more than I did. But that goes to show you don't always need to know exactly what you're doing. You can always learn on on the go. And I managed to, on a Slack channel where I was looking for new jobs, I managed to get in touch with an investor from Japan. And all I knew, I saw in his LinkedIn profile that it said he's the GP of like some venture capital firm. And I was like, oh, okay, I don't know what that means, but it says venture capital, so I'm gonna just shoot him a message and be like, hey, we have an idea, you know? And I checked out the website of their VC firm, and it said that they're into climate and sustainability and life sciences, health tech, all kinds of industries. But I saw sustainability. I was like, yeah, I'm gonna message him. My life, and I think maybe Laura's also, but definitely for me, shooting random shots, like sending out random emails to people and hoping for the best has worked out a lot of times. And this worked out because he was like, yeah, sure, let's get on a call. So we got on a call, talked about Blusink. He loved the idea. He was like, okay, send me a pitch deck, right? Send me a finance model. Show me how this is gonna make money. And again, had never made a finance model in my life. And what do? You ask friends, right? You ask people who've been through that journey. So luckily, I had some friends who had done some startups before, took some mentorship, took some help, took some templates, Google, and we pulled together a finance model for the material. The great thing was that he saw that we had IP and we had somewhat solid looking financial model. And I'm telling you that financial models, if you have done climate science, any kind of like core research, this is quite easy to do. So don't get scared by those kind of things. They're actually quite simple compared to the science that you're doing.
I was gonna say you're already a scientist. You can for sure create a
Yeah,
finance model. Uh,
exactly.
for sure, yeah. And I think, sorry, Banana, I'm just gonna interrupt quickly because
No, no, stop.
a sentence is coming to my mind, and it's also the idea that when you're scientifically trained, you're so trained to deliver a fully comprehended system, right? Like you're so trained to fully describe systems before even daring to speak about the system. And when it comes to founding a science-based company, it is all about the vision and the steps that you're going to carry away to fulfill the vision, right? So a vision is not a lie, even if you don't have a fully working product and a fully, like working business model, because that's what it's all about. It's getting, like driving the funding in other directions that are not just, let's say, profit-driven companies, but also science-based ones to develop those notions of science and to build a concept. So a vision is not a lie, I think was a very key motive for us at the time because we would also struggle a lot with the fact that there was so much science to still do to build a company.
Yep, I mean, we can go to the next slide.
Yeah, okay. I guess we didn't ask
Oh,
the
sorry.
question, so yeah.
Lika had a question. I'm just going to touch on that quickly. So, what are the main elements of a financial model, and is it like how much it costs to implement for X years? I would say it's what investors are looking for is they're giving you money, they want you to make more money from it, right? So they need to understand that this solution is scalable, and it will reach break even at some point. So that's the first step is how long will you take, how many years of R&D are you going to take to deploy something in the real world? How long will that take? And then after that, are people willing to buy it? Do you see market demand for it? Can you sell that to clients? And how much money do you think it will take you to get to that stage? Once they buy, then how long will it take to get to break even, which is, you just making just enough money as much as was invested. And then after that, if you can scale, how fast will it take for you to reach levels of profitability? So how much can you make in profits year on year? Can you be a unicorn? That is something that climate investors are never going to ask because if anyone has invested in climate, they know it's not like finance. But yeah, that's essentially a
But
finance model.
that's very subjective, isn't it?
Yes, it is.
So you just like take one guess and go for that
Exactly.
one.
So that's
Yeah.
the thing. Like
Yeah.
it's never, you can never be 100% sure with like business or finance models. You're just building it out on hopeful
Assumptions.
predictions and assumptions, you know?
Yeah.
And I would say, yeah, they're taking a bet on you. And later we will talk about why that really matters, that they're taking a bet on you and not just the tech.
Eberhard has his hand up.
Yes, Eberhard.
Yeah, thanks. You explained it very well. I just would like to add maybe that the selling starts with finding investors, not only in starting selling products. And so this is also very important. It's a subjective thing, that's clear. And there are investors. I learned it quite recently with another startup from Alfred Wegener Institute, that they would like to come over for 1 week and to learn everything about the people involved and about the business, and to get familiar with it, because they put sometimes really much money in it. And so this is a risk. And what these investors and the venture capitalists do is they invest, let's say, in 10 startups, and they know that only one of them will make it. And so this is a highly risking thing, and therefore, of course, their money is quite expensive in terms of their indeed what they want to get back at the end. But I think what you really mentioned, the scalability and the IP, that helps a lot to convince investors, because, and also back to the IP, if you have an intellectual property right, which is helping to prohibit the usage by third party, then your investment in your own research and development, in your product development is secured. Then you can really convince the investors also. And so, of course, therefore you did very well to go into this, because IP is also quite and the formulation of patents, it's quite a sort of a dry stuff, and not anybody else thing. Okay, thanks.
Thank you, Eberhard. Yeah, and I think also, like, I guess another point, and this might go to a very personal opinion that Anjana and I have to this day, is whenever you go to investors, they're gonna say things like 10x, like the company needs to grow profit by 10 times, which is most of the time not the regular behavior of those markets. So don't be afraid by that either. And I think, when I was mentioning our personal opinion, because it is our personal opinion that more actual researchers need to go for this type of funding, right? Like funding for academia needs to expand beyond grants and go touch on also these type of spaces, because that's what that funding is for. That funding is for uh like also researchers to go grab it and develop more on tech and science by using it, this regardless of creating a 10x profitability company. It's just to build more science and more knowledge, and that's also, absolutely okay, and it should be that way. Um, but yeah, okay, so let's move to the next one. So what do we do at Blusink in more depth, right? I think our vision has always been, when you look at the carbon markets and the carbon space, many of those solutions, the space can be split into two. One part of that space is tech-based solutions to remove carbon. So, that goes to something called DACs, which is direct air capture, right? So these are geothermal kind of like machines that would separate CO2 from the air, quite literally, and then pass it through some solvents. And then the byproduct of that process is going to be something called pure degree CO2. So there are many examples of companies like that. I would say one of the biggest companies in the climate space does exactly that. Is a company based in Switzerland. So tech base goes to everything that doesn't have an direct impact in nature, I would say. So chemical, physical, biochar is well, no, biochar maybe it's also more nature, but like tech base, and then nature base, which would be essentially, and especially if we're thinking about the oceans, which we are, it would be blue ecosystems, so blue carbon, everything we call blue carbon, ecosystem management of mangroves. So we can quantify an uptake of carbon by those ecosystems, seagrasses, seaweeds. So the space is kind of divided. Both spaces have great things, right? Tech-based carbon removal technologies have something that is especially very appealing to investors and to the more financial world, which is the fact that they're very accurate. The accuracy of those solutions is the reason they exist. You can know to a very, nice degree the amount of carbon that they're actually capturing. It's very predictable, right? We all know nature is diverse, and that also means it's messy, right? So with tech-based, you have the predictability of of that carbon that is going to be removed through the cycles of those companies. And I would say, like just to mention those two, just predictability and accuracy of that carbon removal is very appealing about the tech-based portion of that carbon removal space. And then when it comes to nature, as we all know, have tremendous co-benefits that are not just environmental, but also social. So all in all, I would say also nature it should be considered the more scalable end of those two spaces, right? Nothing is going to scale as much as nature because nature uses also the energy cycles of nature. And I would say that's why, to this day, even when we have invested very humongous amounts of money into tech base, still to this day, what captures more carbon are natural ecosystems, not tech-based solutions. So scalability and co-benefits of nature-based is what's good about the other end. Now, our vision with Blusink is carbon needs to mean nature more, right? And we can think about stuff that are technology to nature-based as opposed to either is tech-based or is nature-based. And with that being said, also that carbon removal doesn't need to come at the expense of nature. Whenever we think about these tech-based solutions, we're also thinking about solutions that are competitive with productive ecosystems, right? Just like with terrestrial space that can be used for other type of, let's say, agricultural activities or just the spaces we humans inhabit. So that's also very appealing about ocean-based, right? Which is us. So in our solution, and we'd like to say, it's tech to nature based, and that's the thing that we're pushing the most. Just a new generation of carbon removal solutions that can do both. We have this material, which is the center of our IP. And this material, I'll explain it very briefly, and we also joke about this. So what we do is we manufacture and we sell rocks. But they're not just generic rocks, right? Because that would be a scam. They're very special rocks. And they're special rocks that we engineer so they capture carbon through a chemical pathway. And that's a methodology called ocean alkalinity enhancement, which is essentially deploying alkaline minerals in the water. So they buffer that seawater and create a chemical reaction that transforms CO2 into bicarbonates and carbonates. So that locks the carbon away and that locks it into other carbon species that are present in the ocean. That also colonizes the places we deploy locally. And that carbon capture, because it's tech-based, it's more on the tech-based side, it's predictable and is accurate, right? Like there's a good level of accuracy that you can get through just the chemical reaction, right? So it's going to be a function of the mass of those alkaline minerals that you deploy in the water. That's the first phase of our carbon removal process, right? But it doesn't stop there. And we also want nature to kick in to also provide the environmental co-benefits and social co-benefits we're talking about, and to be scalable, because then again, like, let's not forget, at the end of the day, there's nothing as scalable as nature is. So it doesn't stop there. It's also engineered through a physical matrix to target something that it's called rhodolites or coralline algae, right? So we'll show you some more photos, but essentially, our first phase as a company was deploying this in as many geographies as we could to test exactly that I'm saying, right? Like this thing, whenever is deployed, is going to target specifically species that are reef building species, or carbonate-based species. So we weren't targeting as much the fleshy algae, the turf. We were targeting things like coralline algae, sponges, polychaetes, and we were seeing how many juvenile fish species would be attracted to these areas because of these species that were colonizing the material, like the material was transforming into. So this is a quick photo of a blusinky. We call them blusinkies. Each rock is a blusinky. So this is a quick photo of a blusinky, and this one particularly was one of our first ones that were deployed off of the coast of the Colombian Caribbean during that COVID period. And this one here was deployed for something around 9 months. So what you can see there is very fast colonization of coralline algae, which is, we're getting the science to back what I'm gonna say, but we believe it's faster that, like whatever happens in naturally decaying structures, right? So a piece of coral that, let's say naturally decay or maybe, bleach because of ocean acidification, the rates in which the material transforms into a living rock again might be faster than in these naturally occurring materials. So this is another image of, through our IP, and this goes to the relevance of IP. We also filed the fact that we could manufacture this material in different geometries, sizes, and shapes. And the reason why we did that is because we knew this was going to be a blank canvas to be deployed at different type of ecosystems, right? So we were not thinking about deploying at just rhodolite beds or coralline algae beds. We were thinking about applications like kelp, right? What geometries would be useful for kelp? What geometries would be deployed on the seafloor, maybe have the capability of rolling on that seafloor, and through that mechanical friction, get rid of sedimentation or green algae that sometimes suffocates, for instance, things like coral restoration efforts. So this is one of the other geometries. This is something that we've tested in some of the geographies as well. We've deployed at. And something very special about developing the tech is from the business perspective, we've also been able to expand our vision and think about things like circularity. So when we started the manufacturing of, or when we started, like developing the concept of the material, we were using, because it was at lab scale, we weren't realizing, for instance, the type of alkaline minerals that we were putting into the mix. The source of those minerals was important because the scalability wasn't really creating a pressure for it. When we started thinking about a company and manufacturing thousands of millions of this, and this goes again to the importance of researchers founding more companies, because I do think we're more fine-tuned to actually be concerned about these things. We started thinking about, like, we cannot do it with minerals that are going to create a new mining pressure, right? So we started researching about what types of minerals were maybe waste products of industrial processes. And we created more IP to be able to outsource waste minerals, sorry, from industrial processes. Like, for instance, marble creation is one of those processes that have a bunch of minerals that can be used into things like oceanography enhancement. And nowadays, we are able to manufacture, blusinkies that are up to 50% of the material is an upcycle mineral that we get from these industries. I'm not gonna make this very long, but that creates even new avenues of opportunity in the business world, right? Like that creates an opportunity for you to offer material management protocols for that type of industry. And that also goes in the same circular solution. So this is a close-up of the blusinkies. I think this one is also from Colombia, but different reef. And then essentially here you can see how the material transform. I think this one is something like 6 or 7 months. So essentially, the key concepts that we're handling right now is, like when it comes to biodiversity, it definitely enhances the 3D structure of that seafloor that creates hatching spots, housing spots for many juvenile species. Hopefully, also at scale whenever we deploy, and the Blusink is intertwined between each other, also are creating the three-dimensionality that is needed for coral larvae to settle naturally in those structures, right? So not a sexual reproduction, coral restoration strategies, but just like for the larvae to settle naturally on the structures and catalyze recruitment of all the trophic levels, just, like a foundation for species to growth after the carbon removal process has taken place. And then as of now, and this is more again like business framed, but as of now, our big vision is because we have this carbon removal potential that belongs more to the tech base. We want to combine that to nature base to also bring those sources of funding to restoration efforts, right? Like restoration mostly suffers because they don't, they struggle to get continuous revenue and continuous sources of funding. So, philanthropic funding is amazing, and continuous revenue also is, because that means continuous funding, right? So at the moment, we're testing coupling the solution with restoration sites and testing something that we call compatible ecosystems, which is how many of these ecosystems we can deploy with Blusinky so they can share profit with us, the carbon credits. We're going to be good for those ecosystems because in any case, the material assimilates into nature on those places. And then we're going to bring the whole picture, which is continuous revenue for those restoration efforts as well, so they can grow. So seagrasses is one of those. We're right now, Semarine is actually, I think, a partnership of a German university called Gießen. But essentially, Semarine is a scientific institution in an island in Colombia. We're testing on their coast, which is something like 1.3 kilometers, how to like manage the ecological connectivity of those fragmented patches of coral reefs, seagrasses, and other ecosystems with blue sinkies. So there's a study going there, and essentially what we want to touch on is also on bringing the concept of blue carbon to those efforts, right? There's a lot of blue carbon that is not quantified, and that's a reason that we're missing to protect those ecosystems as well, just providing the economic value of nature on those places. Seaweeds, we're also thinking about them. So like, we're this year jumping on a new pipeline to investigate the capacity to accelerate growth, probably through that alkalinity, local alkalinity that is exerted, productivity. Here's a shout out for macrocarbon, which is maybe some of you know Mar Fernandez. She's also part of the community. We met her through the community, but also at was that an acceleration program? How would you call Hatch Blue?
It's like a quick acceleration program. Yeah. Sorry,
Right, so
Laura,
Hatch Blue.
just to know, we are running out of time, so maybe we
Oh
just
yeah,
keep.
sorry. So
No worries.
macrocarbon and then coral reefs, which is what we've done for a long time now. We have a study with Derby University where they tested different substrates for coral larvae settlement. Our material really excelled there, so we're hoping we can publish all of those very soon. And this is a quick map, so you understand the scale of Blusink right now. So we started in 2023. We incorporated the company, and this is all of the places we've deployed Blusinkies as of now, right? So many interesting geographies there. We hope there are many more to come. And just again to say, our scientific background did a great thing here because many of those were leveraged at the very beginning through partnerships with research institutions on those areas as well. So science is it's just very important to keep still science at the center of all of it. Yeah. But do
Yeah.
you want to go?
Yeah, sure. So the last message that we had to deliver was resilience more than brilliance, because we've met in our journey a lot of great scientists, great companies with great tech, right? And I don't know if you guys know the statistic, but I think it's over 90% of startups that don't make it past the death valley. So the death valley is around the 2-year mark for most startups. When funding dries up, they're not able to raise funding after that, and not able to bounce back from, from their funding problems, but also to reach scalability. So going from having great tech to making it scalable requires resilience to failure, and also resilience to market ups and downs. You need more than just great tech. So, next slide. Yeah, no, just next slide. Yeah, so science, like we said, rigorous, precise. We always need more research. We need more research before we publish. But entrepreneurship, what we got slapped in the face with, I would say, is we need to start talking about it right away, right? And it's very need-based. If the market doesn't need something, they're not going to be as willing to give you attention as if it's a problem that they really need to solve right now. So we need to make narratives that are able to convince people that this science is necessary, and it is, but most of the time industry is too busy solving all of their other problems. So all of this we had to learn in that path. Next slide. Yeah, so finance versus science models. In finance models, what we are supposed to do is allocate capital, right? Scientific models are built to understand system dynamics, but finance models are like, we have money, where do we put the money? Like I said, if you're a science person, honestly, finance is simple to understand. In science, we're optimizing for explanatory power. We're looking for validation from the rest of the community. And, that's why you have peer reviews and all of this stuff. In finance, you are looking to execute fast, fail fast, so that you know what doesn't work fast, right? Because you don't want to keep spending money on making sure that something is like super perfect. You just want to get stuff that doesn't work out of the way quickly. And then last thing is it's designed to price uncertainty versus pricing scalability. Next one. So cultural shift, right? We need to practice a cultural shift when you're going from academia to business. Like I said, in academia, you avoid overstating your scientific premise. You're like, we think that this thing causes X causes Y with a probability of plus minus 20%, right? And then you want to be very cautious when you're talking in academic terms. And both me, Lore, as well as some of our employees, especially like doing R&D, have made the mistake of being too cautious when talking to business, when talking to clients, right? When you're talking to a client, they don't want to know that there is 60% risk associated with it. They just want to know that you can make it work and you'll figure out a way to make it work. And you're going to do that fast and on as little money as possible. So just don't wait for perfection is what we're trying to say here. And be willing to execute things fast. You don't have long timelines in which you can, do the research, publish the paper, wait for peer review, go back, do the research again, because the funding is never stable. I mean, I'm not saying it's stable in science, but not really stable in finance, especially. So to build powerful climate tech, what do you need to look at? You need 3 main things. It has to be scientifically rigorous, it has to be economically scalable, and you have to be able to deploy it. And you might think that you have some of those things for the tech that you've invented, but you have to really understand what this means. So for example, you can have a tech that's scientifically rigorous and operationally deployable, but is not scalable. For example, that could be in the coral space, at least, it could be 3D printed clay, right? It's scientifically rigorous, you can deploy it, but how cheap is it to scale, right? How many local communities around the world can do it affordably to protect their coastal ecosystems? So if it's not scalable, then you have something great, but you can't really sell it everywhere. So you're never going to reach a level of profitability that investors would want you to. The other thing is economically scalable versus and operational deployable, but not really scientifically rigorous. This, I think, I don't really need to explain because obviously if the science is not really working, then you are at a very low TRL stage. You're not able to take it out of the lab, and you don't really have a good business case in this. Economically scalable and scientifically rigorous, but not deployable. What does this mean? So you can have something, for example, there's some tech, maybe like some types of like green hydrogen or some kind of like very advanced like next generation tech that is scientifically rigorous because there's enough research that has been conducted to show that it works, and it is scalable because the energy industry needs it, or there are massive industries that need it and they're willing to put money into it. However, right now, these industries don't have the capability or the machines required to plug this new tech into their systems, right? So they have to do a lot of systems changes within their structure to deploy these kind of tech. So there's a big barrier standing between you and actually getting the client to use it. So that's what I mean by it's not operationally deployable. It could also be like regulatory stuff, like the countries just doesn't have those regulations in place. Yeah, and then the bonus tip, mentorship matters. This is the final thing that we're gonna leave you guys with. Both Laura and I have been quite blessed to have mentors along the journey. And without this, I don't think we would have gotten to where we are. Definitely wouldn't have gotten to where we are because when you hit roadblocks, you need to talk to someone who has been there, right? And you want to find some kind of mentorship. I mean, look, if you are in science, you have professors. You have someone to ask questions to, right? Like you have postdocs, you have someone who's been there, who's been in that lab, done that stuff, and can tell you exactly what you're doing wrong. The same thing in business. And people don't talk about that in business world enough, that good businessmen always had good mentors. So they always had someone to like bounce off their ideas, bounce off their problems. Again, you're not the first person building a business and you won't be the last. So someone will be there to help you, and you need to find those mentors fast. Next one. Last one, people skills plus research abilities make a business, right? So you have great science, but something that that I said earlier is investors invest in you, not in the idea itself. So people invest in people. And I have seen startup founders whose ideas have failed, whose companies have had to shut down. They weren't scalable, but their investors said, you know what? I don't care what idea you're coming up with next. I want to invest in it because they believe in the person so much. And these are things that, we've never seen in academia because obviously you want to invest in good science, right? But in business, people connections matter a lot as well. So even if your tech is not completely done yet, you can convince investors to put money into use to develop the R&D further versus someone who they just don't like speaking to. So never forget to stay humble and be nice and be a good person. That's always going to work in your favor. So build these soft skills because soft skills are actually very, very important in the real world. That's it. Thank you all for listening. And sorry we went over time.
No, that's wonderful. Thank you so much. So there are a few questions in the chat, including one from myself. So you mentioned that you're looking forward to have more testing sites for your Blusinkies. So what else someone needs to have to collaborate with you besides having access to a testing site?
Besides that one, I would say, like at the moment we're there. I'll make it anecdotal again. We're talking to plenty of foundations, for instance, and just like, aquariums, people that have regulatory access to the maritime areas. Because what we're doing right now is coupling the technology again with restoration sites. So, I guess beyond that, the work is all ours, and we often do it in collaboration with those local access providers to find the sponsor, right? Because all of the projects are ideal if they have that local operator. So we're sure, like we also get access to the local science, which is very important to understand the sites. Like I think we're all experts here in those in that side of the matter. But then the second phase is find a sponsor that is willing to, sponsor and support the project financially throughout the stages, right? And that's the combination that we have with most of the deployment areas at the moment, right? Like, if we think about, I'm in Colombia at the moment, right? So like if we think about like our project in Colombia, it's a big company in Colombia sponsoring that restoration operation, but we're also in collaboration with an NGO in the island where we're deploying, right? So I would say, um, what else is needed to collaborate? I would say just like if you're participating of a restoration effort at the moment and you think this solution could help the area, just like reach out to us. We have some experience in like gathering that support of a financial sponsor, and we can brainstorm something together for sure.
Excellent. So Eberhard is asking, what is the situation regarding permits for the deployment of the Blusink kits?
Yeah, so like so far again, like we've done it through foundations or NGOs that already have regulatory access to those areas. That includes the permits to deploy in those areas. We, of course, alert environmental authorities we're going to deploy, but we do it through that previous networking, which makes the process so much smoother, right? For other cases, whenever we've deployed at ports, it's kind of the same process. It's just having the right local partner so they can help you navigate the local authorities. And when it comes to Blusync specifically, what we gather were essentially the protocols, especially the international protocols that were specifically drafted to indicate what's safe or not to deploy in marine ecosystems. We're very lucky the material is not complex that way because it's still a biogenic inert material that would it screens well for that type of protocol. And then, of course, there's a quality assurance process involved in which we check each batch that we're going to deploy. Whenever we have import-export operations, that's also required. So I would say it's just a set of understanding the permits that you need to go through and kind of like make them very mechanic so you can scale it with the company.
How does it work, Lorena? You deploy it and then it stays there for a certain time, or it's indefinitely?
It's indefinitely, like it's designed to be deployed and stay in the ocean, precisely because we wanted to serve a restoration purpose as well. Oftentimes we retrieve a couple of units just so we can,
To
study
measure.
them, check them. Research institutions also do that because, like they have their own research objectives, which is also we're very something we're very friendly about, right? Like whenever we deploy, it's always happened that the local researchers have research ideas around the material, so we provide a couple of units so they can also conduct research on the material, right? Many times it's coral larvae settlement, other times is just carbon cycles associated to the organisms growing on them. Yeah, there's a lot in the
Good.
mix.
Another question from Eberhard. To what extent are investors reluctant to invest in a marine business? For instance, in bad weather, a lot of money could be wasted on sea trials.
Yeah,
So let me
yeah,
concretize this a little bit more.
Yes, please.
We learn to know a lot of investors who are hesitant to invest in blue businesses because of this quite expensive logistics out there, and so you can burn a lot of money in a few bad days, and so they maybe it's more easy to invest in a software development or something like this. That's so no bad weather. And what is your experience with this?
yeah.
Yeah,
I would say there's definitely more funding allocated to the SaaS type of business, right? Yeah, go
yeah, I
ahead.
would also say there's I mean there are specific funds, right? Like Catapult and Hatch Blue, and they're like funds that are only for that, and it's a very small community, just like the marine science community. Like you know one professor, you know another one, and then it's like a very tight-knit community. Just like that, like the ocean investors are also quite, it's a tight-knit community. And I kind of find it is a little unfair that when you are a climate, especially like a marine science solution, your tech has to be so much more advanced or proven to a much better degree than, let's say, a software solution, because there's a lot more free-flowing money for those kind of things. However, there's different angles to look at it. So there's equity investment angles, and then there's grants, and then there's also nonprofit funding. So I think it's good to also look at other avenues. I know grants are slower, but if you have a really good idea, then there's a lot of like small grants from sovereign wealth funds as well.
Yeah.
Good. So the next question is from Siafaya Naila. I apologize if I mispronounce your name. So she's a first-year marine biology student in Indonesia, and she's really excited to listen to you guys and overwhelmed because there are so many directions you can go. Yeah, that's right. So she wants to ask, as early undergraduate students, what specific skills, habits, or experience should we start building from now to better prepare ourselves for a future career in marine research, conservation, or international marine organizations? What's your take?
I would say like apply to as many, like I said, shoot random emails, right? My first, just one anecdote, and then Laurie, I want to pass it to you. But one anecdote is the internship I got at Potsdam. I woke up one day, I was like, this summer I need an internship. So I went to Google, I was like, climate scientist Germany, because there was a grant that allowed students from my uni to work in Germany for under a professor, but we needed an approval from a professor. So I Googled like climate scientist Germany. The first name that came up, I just shot him an email. And I got an internship there, right? Like I'm not saying that's gonna happen all the time, but I'm saying like shoot your shot, like we did with the investor. So just keep applying to as many things as you can and get as many internships under your belt as you can. All right.
Yeah, I would say like also maybe, like before you even, because I think for you it was because like you already knew it was climate science, right? But I think deep breath, and before you like you let the overwhelming, like feeling take over, just like also, dare to reframe the question, like because it's sometimes like not also like what you necessarily need to build to serve a certain community, you think like, to serve, let's say, coral restoration efforts because you see that's the most mainstream thing in the space right now. It's also like just like you're young, take those years to figure out what you're good at and what you truly enjoy. Um, and that's the thing you're gonna be the most successful at, right? Like, passion, science specifically, because I think all of us people that went for a science career is because we were able to prioritize what we felt good at and like what we felt a passion for over am I gonna make enough money or whatever other thought, right? Like so like passion is a really great opportunity to build a successful career. Like don't forget that, right? Like take your time, understand what you're good at, what you want to do, and then shoot your shot. I would say like that's kind of like the next phase of that.
I would add experiences to your so the best way for you to learn if this subject is something that is interesting to you is try to associate yourself with research laboratories or helping NGOs on their activities in conservation and something like this. You're building your curriculum and you're learning different aspects. It will make easier for you to decide which direction to go. Okay, so I think this is going to be our last question because we're running out of time. We'll run out of time already. So it's from Lamona. Lamona Bernaus. Have you been participating in carbon trading? Who are your potential customers or buyers?
Yeah. So, I mean, there's still, like we're a young company, we're still validating who the client segment is gonna be, but we've got to narrow it down quite a big deal, right? So there are two avenues right now, and there's, when you talk about a company, and this is very similar to the scientific world, so I just want you to take that as to the scientific method is really applicable to every every possible, effort you do in life. So whenever you have a company, you have something that is called strategy, and you can take that strategy as your hypothesis that you're testing whenever you're trying to research something, right? So our strategy at the moment, and the thing we're validating is out of passion, if we can scale carbon removal at restoration sites, so we can profit share with those restoration efforts that are oftentimes just fully dependent on philanthropy. And that can also be, like a very wise business model because it can help us scale fast, right? Like it's building the protocol, handed it over to all of those restoration sites that already have the expertise. So that means we also wouldn't need to grow the operational knowledge. And that's kind of the strategy that we're testing at the moment. That would make our clients everyone that would need to offset carbon. Another client segment that we're also validating is every company with legs in the sea. So that would mean ports, offshore wind, like projects. So oftentimes those have a lot of something that we pitch as unutilized seafloor space. And because they have that unutilized seafloor space, deploying something that would translate that unutilized seafloor space into profitability is, of course, another potential business model. And then to the question of have you been participating in carbon trading? So, like yes, to a certain extent, like for instance, we're part of different carbon markets in their coming soon feature, right? So carbon markets are essentially, carbon trading platforms in which things like carbon offsets get traded. It's the case of a client purchasing carbon credits from the carbon developer directly is very rare. How it works is the carbon markets, there are companies that specialize in that business specifically. So they're essentially the bank, right? They centralize the carbon credits and they hand it over to companies so those companies can also, understand that there was a disinterested third party involved in the process of validating, verifying the quality of those carbon credits. So for a carbon developer like us, it looks like, are you in contact with carbon provider, like carbon markets? So yes, we are. Like we have touch on different carbon markets. You can find us maybe on some websites on those on that coming soon feature. At the moment, we haven't actually sold carbon offsets because we're still in the process of verifying them, right? So that's kind of a long process, and although we've been 4 or 5 years with the company, that's a very young age for a carbon company to sell credits. So it's still in the process. Yeah.
Very, very good. So I overseen, but Amabel has her hand up for some time now.
Hi,
Hello.
hello.
Hi.
Nice to see you. It was really a great talk. I'm so proud of you both. And I just want to ask actually about the scale of the Blusink. So in how much of CO2 can one structure actually capture over its lifetime? Just curious.
Yeah. So we're talking about, and this is sort of like how we pitch it. When you capture carbon, it goes to efficiency. So, like how much carbon in how much time, and then durability, which is essentially once that carbon is captured, like is it going to be released back? What's the risk of that? Is it permanent? So, in our case, we pitch it as this thing is at least 10 times more efficient than forest, which is the thing we invest right now, as of right now, the most. And it's permanent, which forests are not, right? Because a forest can be set in fire and release all of that carbon back. This is a rock, a mineral rock. Even if it breaks, it's just gonna release the alkaline material again and be bicarbonates. And then the reason why we say 10 times, more efficient than forest is because that's what the chemical part indicates, right? So we've had the opportunity to inspect the type of minerals that go into the material and how would that behave, how that would behave when it comes to buffering seawater, colonizing and transforming the carbonate species in that volume of water. So yeah, a number per unit is something that we're really excited to get, and that takes a very specific study that we're planning to conduct this year. But then what we have right now is carbon capture per kilograms of material. And then we just make it area, right? Because that's what the space is used to, right? Like whenever you talk to, let's say, a carbon investor or even a client, they want to think about it in terms of tons per hectare per year. So in that case, it would be 10 times more what a hectare of forest does usually.
Okay. How heavy actually is one Blusink key, like in terms of
It's very
deployment?
light. It's
It will not
so
be like taken away when like there's storms, especially in the tropics, like when
oh
there's
well, storms. Let me bring one. I have it right behind me. I'll be back.
Yeah, it's
But
like
yeah.
it's around 100 grams, less than 100 grams. And then for number, like with the alkalinity, we found around 170 tons per hectare, which is a lot more than mangroves also. So yeah.
Yeah. And then each one is something like, we have different shapes and sizes, but let's say the lightest one is 80 grams. The heavier one is something like 200 grams. So it's not very heavy, but also like whenever you deploy them, because it's very porous, it fills water, just like fills the material, so it's heavier in the water. And then when it gets colonized by calcifying organisms, it also kind of like, it's gonna build into whatever rock you deployed on. Like it's just gonna stick, yeah.
thanks.
Great to see you, Emil.
Good to see you.
Okay, so a little reunion here. Very good. Very good to see you all. So I want to thank everybody for your active participation and for sticking with us. Thank you so much, Anjana and Lorena. I too am proud of you two and to be witnessing these amazing things you guys are doing. So thanks everybody again and happy weekend.